Good afternoon, everybody. First of all, thank you very much to the CTBUH for this opportunity, and how great to be with lots of colleagues today talking about this important subject. Okay. Just a very quick bit about Horizonscan. I'm a fire engineer, but at the moment my business is very much linked to resilience in tall buildings, and I'm going to try and talk about what that means for the future of tall buildings, building on some of the points that were made throughout this session. Simon rather stole my thunder. 2007, according to the World Health Organization, was a significant year. It was 2007 that we reached the tipping point where we've got more people living in cities than we have in the countryside worldwide. We now have 13 world cities with over 10 million residents, and surprise, surprise, Shanghai comes out top at 17.8 million. I'm not sure if that figure's accurate, but that's an awful lot of people. The rate, size, and complexity of tall building construction is also increasing rapidly, and seemingly they are the cathedrals of our age, where everybody wants to have the most unique, the tallest, the most unusual tall building. And we are surrounded by architects. I have a love-hate relationship with architects because they tend to present me with all the problems and ask me to sort out their design issues. If I was to ask all of you in the room here to put your hand up if you've got a very clear understanding of the definition of a tall building, could I just ask that? Could you put your hand up if you can absolutely define to me what a tall building is? Okay, one or two. That's kind of interesting. I'm going to talk about that in a minute. Building codes and fire strategies and maintenance. This talk is about management specifically, but I'm going to branch off into some other areas as well. I'm also here to promote the work of this group that I'm involved with. This is the Tall Buildings Fire Safety Network. It's an international group, and I think we're kindred spirits with this particular group. I mentioned that to you that you might want to consider it if you want to get involved with it. It's an open network around the world of people who are looking specifically at fire safety issues. And some of the people are in this photograph. This was our conference in this year. Some of the people at the top there, and we had a dinner below. So, and I think we had 18 countries represented at that conference, and we're repeating it next year. So this is the definition that we've worked up as a group. I can tell you that this took a little over 2 years and a huge amount of controversy and debate amongst the group. And in the end, we opted for simplicity. So a tall building is a building that has occupants that reside above the reach of ground-based rescue ladders, and the evacuation of the occupant relies on internal escape routes. Now, you either agree or disagree with that, and that means that some relatively short buildings are tall buildings, if I can use that term. But it does help us to try and work forward this, and clearly there are super tall and mega tall buildings that we've already spoken about. For me, when I'm developing fire strategies, they are really the output from three things. This is my triangular fire. We've seen a few of these over the course of the day. Clearly we've got the design. We need to think about human behavior, which is an important component of the design, especially when we're now starting to talk about multi-occupancy buildings. And the essential element, as far as I'm concerned, which is the management of the building. Now, when I'm talking to clients and trying to get them to consider their building and what they want from their building, we heard earlier on today, the other session about, again, about management of the building, about whole life costs. So this is a concept that I use to try and get building owners and developers to think through the issues to do with investment in the building. And I call it the fire risk corridor. And the proposition here is that you're starting from the left-hand side and you're working down this corridor to the optimum solution. We know that we have to satisfy legal compliance, and they're generally detailed by the codes and standards that may reside in any one particular country. In my experience, in terms of risk, they're pretty low. That means everybody gets out of the building, or everybody stays alive. That's the proposition with those. So it's actually a fairly low level of risk mitigation. We know that if we go a bit further down this corridor, for all of the design fires or the foreseeable fires, that everybody gets out and the building will pretty much be salvageable and be able to be reused. If we go a bit further down the corridor, then everybody gets out, the building stands up, and if you have a mission for the building, if it's a could building, then you could be able to continue that mission to a large degree. And finally, we have what I call full flexibility of use, where the investment in the building fire mitigation is so high that it really cancels out the foreseeable fires. And of course, I have to then distinguish between the normal fires that we see and arson and terrorism. And arson is the fastest growing cause of fire in the UK at the moment. And it's interesting to note that 50% of that arson is employees or people inside the building who are employed in the building. A rather salutary thought, because they know where all the systems are and they can be mitigated. Now, the accepted wisdom here that is the further you go down that corridor, the more you have to spend in terms of capex or the cost of the project. It's my contention that if you do, and if you could assume this even over a 25-year life period, that the more you invest in the building, the actual OPEX of the building over that 25-year period comes down, because you can move walls around, you can change the fire loading in the building. But this quite often doesn't get discussed in project stages because they're looking at a simple capex cost. And as a fire engineer and trying to get people to think through resilience, this has helped me quite a lot to try and get, especially the people who are looking after the money, to think about costs in whole life terms for the building when you're putting systems in. When we're designing fire strategies, we have to think, for me, it's an outcome from these 6 combining tactics, and they are prevention, detection and alarm, escape, containment, and that's passive systems and also active systems like sprinklers, firefighting. Now, back in the day, I was in the fire service in the UK, so I used to have to go and put fires out inside buildings, so this is a subject close to my heart, as you'll see from some of the other comments I'm about to make. But coming very much more to the fore, and looking to the future, business continuity, or the emerging term that we're seeing now is resilience, is going to be particularly important for tall buildings in the future. And I believe it's something that has to be put on the table at the design concept stage. We know from previous work from the NFPA, John Hall, we can identify what the main ignition hazards are if I discount arson and terrorism. And they are, as you can see here, electricity. Quite a lot of those fires are to do with lighting, proximity of lighting to combustible surfaces. Catering, all forms of catering, but in my experience, there's a lot of issues to do with kitchen extract systems and the disposal of grease vapors inside kitchen environments. Hot works, control of contractors that come into buildings. I'm staggered as I work around the world at the number of people that don't understand what hot work is, especially contractors who are doing work, and it's not. And the worst culprit is angle grinders that I see being used in lots of buildings, and people don't think that that is hot works. I've mentioned arson before, and lastly, smoking. It's interesting to note that we've just had the first case in the UK of somebody who was illicit smoking, i.e. smoking in an area, and they started a fire which burnt a building down, and they've now been, they were sent to jail for 7 years because the judge said it was arson. So I wonder how many of you out there thought that illicit smoking was arson, but we now have case law. And speaking to a colleague in New York, it would be second-degree arson. So in the US as well, that illicit smoking is arson, according to the law. Now, anybody got any ideas what that is? Today's quiz. Any suggestions from the floor what they think that is? Anybody? Well, I can tell you, it's the final discharge of a kitchen extract fan on a very tall building that I was auditing and looking at. And as I was standing next to this fan on the top of the building, this was flicking grease at me. My shoes were covered in grease. And this had the normal catering that you'd expect in an office. This was a multi-use building, so it had some retail on the ground floor. It also had some other catering through the building, and this was one of the final discharge points. And I was surprised at how much grease was being conveyed through the system. So I traced the system back to the kitchen, and this is what I found in the kitchen. This is a kitchen grease filter that's fitted above and inside the kitchen. But it wasn't in the filter. It was standing next to the side of the cooker. And that's because it was completely solid with grease. And I asked the people in the kitchen, I said, why did you take the filters out of the extract system? They said, well, it was terribly hot in here while we were working, and we found that if we took the filters out, the airflow through was a lot better and we could cool the kitchen a lot more. I don't have to, hopefully, try and make the point here of how dangerous this is in terms of what a fire would do if it got through the extract system. So I've spent quite a lot of my time on behalf of insurers now looking at kitchen extract systems, and they feature quite highly on the fire statistics that I have seen. So we can build the most elegant, most challenging designs for tall buildings that there's ever been. But the challenge for people that then take over that building is to manage those risks. And we just heard from the previous speaker about passive fire barriers. Quite a lot of my work is also about fire barrier integrity. And I can tell you, I can go into buildings that are barely 18 months old and look at some of their main fire barriers, and they are just covered in holes where people have taken pipes and cables and data cables and telephone cables through them. So the management issue is absolutely vital, that we stay on top of it, especially as we look to the future. And I mentioned human behaviour. This is social housing, and I'm not sure if we've touched on this to the extent that perhaps we should do, especially bearing in mind Simon's words about the number of people that may be residing in these kind of premises. But this is some extreme behaviour from some people in a high-rise building. This is in Canada. So the balcony that you can see there, that is not material that's been moved out of their front room. That is their normal state of play. And as you can see from the flat below, the one that's covered in material, that's an air conditioning unit. And that air conditioning unit is the same in the flat above. So buried in amongst all of that material there's an air conditioning unit that's trying to work. Interesting, when we were talking about the legal aspects earlier on about right of entry into this type of building, in my experience in lots of countries, trying to get right of entry into somebody who's perceived to be quite dangerous from their behaviour and how they conduct themselves is not easy. And it's an issue going forward about how we can make sure that this kind of thing, this exceptional behaviour, which is clearly very dangerous in terms of fire, is something that can be managed. So we have some new challenges. I mentioned BIMS earlier on. If you don't know that acronym, it's Building Information Management Systems, and they are coming. If you haven't seen them, having read the new ISO standard on BIMS, if you're involved in new design work, then you really do need to be up to speed with BIMS, because BIMS is going to revolutionise design and the way that we design within CAD, and we run systems and we simulate systems working inside buildings, how they're going to be built and constructed going forward. What it also allows us is, it's a Pandora's box, it's going to make us be able to come up with all types of different scenarios for fires going forward. So as a fire engineer, if I link the CAD drawing to some of the current fire design systems, we can run a number of scenarios for fires in buildings. And I believe that in a reasonable space of time, there will be algorithms that we can employ within BIMS in real time connected to the fire detection system that will give us optimum solutions for escape. So the building will think for itself, connected to the sensors that are inside the building, connected to people's smartphones, and we can see hopefully some very elegant solutions coming out of that for the future complex buildings. But clearly that's going to need to be managed. But that is coming, I believe, is my opinion, that you're going to see some very innovative design evacuation strategies that are going to be linked to BIMS in the near future. It's an order of magnitude more complex than some of the things we've got out there at the moment. We are going to have to use lifts. There's no question in my mind that lifts are going to have to be used for a whole number of reasons, and we do need to work through those issues and make sure that we use them in a smart way. Multi-use, multi-occupancy, the vertical village concept, it's already here. It's happening in a number of buildings that I've been to where you've got residential, hotel, office, leisure, public access for viewing decks, retail, serving alcohol, people asleep, people unfamiliar with the building. The the days of the single use, I think it's been said a number of times today. Some of the things that you might have to bear in mind for future is denial of fire brigade response. More about that in a second. Prolonged power interruptions. For some parts of the world, this is not uncommon, but there are good reasons why we might suspect that it might be happening in other places. And we are going to have to think about high-rise timber construction. An architect said to me the other day, within 10 years you'll see the end of concrete and steel. I think that's rather ambitious, but you're certainly going to see a proliferation of timber frame, especially low-rise timber frame to start with, but I saw a paper that was produced recently where they're talking of 50 to 60 floor timber frame buildings. Now, that may make you nervous. I can tell you as an ex-firefighter, structural steel loses 2/3 of its strength at 525 degrees, and it goes like plasticine. Sorry, it becomes very deformed, and if you're inside a building trying to fight a fire and the steelwork is unprotected, it's not a great place to be, especially when the roof comes in on you. So talking about resilience then, in the US, Hurricane Sandy's had a profound effect on some institutions that have their offices in the areas that were affected. A lot of the tall buildings had their diesel generators for sprinkler pumps located in the basement, and we know that they were flooded. So what you then have is the worst of all worlds. You have your probably your largest tangible assets, your office building with all your servers and all the rest of it in there, and it's got no active fire systems effectively because you've got no sprinklers, you've got no wet risers, you've probably got no power for some of the other systems. Some of them had standby generators. Again, they were in the basement. And they had enough fuel in there for 48 hours. Clearly not enough. That went on in some cases for 2 weeks. I heard stories of diesel refueling trucks having to have armed guards on them because people were trying to get hold of diesel. The other thing you might want to bear in mind is denial of exit staff. During the Olympics that we had in London, a number of organisations had to actively plan for their staff not being able to go home at night for whatever reason. So if you have, as we heard today in the Shanghai Tower, 30,000 people, and you're then told that none of them can go home at night, they've got to stay inside the building, that's quite an interesting challenge as to what you're going to do with them. Denial of fire service response is certainly something that I'm having to deal with on my in-tray with some clients. If your fire strategy is predicated or based on a fire service response, what do you do if the fire service or the fire department doesn't come? They're not going to come. And there's several reasons why that may happen. In Hurricane Sandy, the fire department was already completely overwhelmed. So there's no way that they were going to be coming to answer fire calls for certain buildings. It does change the parameters of the proposition when we're talking about how resilient you make your building. I'm actually talking to clients now that are actually discounting the intervention of the fire service. And that's going to lead to a whole different approach. And if you have time, I'll be happy to discuss it with you, but I think we're going to see some new emerging technologies. In London now, we've deployed a thing called, the fire service has deployed a thing called a Cobra branch. This is a very high pressure branch that can punch holes in walls and fill a space full of water mist. I would not be surprised if we don't see some kind of addition to the wet rising main that's boosted and the deployment of these kinds of branches inside buildings, because it means that you don't have to go into the compartment. I'm getting off the subject here, but what I'm saying is that depending on the environment that you're working in and depending on the area that you live in around the world, there are many places that have to design for no fire service response. And we've heard because of traffic, because of extreme weather, whatever else it may be. Something to bear in mind when you have these enormous buildings with tens of thousands of occupants inside. Timber frame, despite this photograph, which is obviously a dramatic photograph, this is a relatively short timber frame building which was nearing completion but caught fire. Timber frame, when it's under construction, is extremely vulnerable to fire. When it's completed, it should represent no more of a risk than traditionally built buildings. Thank you. So, with the Tall Buildings Fire Safety Network, we have some work for this year, and I'd be delighted if anybody would either like to be consulted or informed or would like to be part of that discussion. We are writing a guidance document for evacuation inside a building for the kind of threats that you might need to evacuate for. We're writing a generic fire safety policy for a tall building. Fire safety training needs analysis, so we're trying to draw up a training matrix that defines competency for all those that are involved in fire safety in a tall building, be that from the emergency director or fire safety manager down to the security guard that may have to respond to an alarm. One thing that I think you should all be aware of is the debate around the calculation of EMLs. EML is an insurance term, estimated maximum loss. If you insure your buildings, if you self-insure, then it's not an issue for you. But if you insure your buildings, then it's somewhere someone has calculated the estimated maximum loss inside that building. And generally, they're talking about a fire on one floor that may affect 2 floors or 3 floors with water damage to 3 or 4 other floors. What we've seen in the last 3 years is we've seen fires in tall buildings where there has been multiple seats of fire because we've had burning debris falling down the building, setting fire below it, so we have multiple seats of fire. Or if the facade of the building is not correct, we've seen whole height involvement of the building. So the fire is burning the whole height of the building, which has led us to believe that there may be some current shortcomings in the way that we calculate EMLs. And if that's true, then that means that there may be some tall buildings out there that are underinsured. We are holding our 3rd international conference next year in London. There's more details down the front here if anybody'd like one. We had a conference this year and we produced some proceedings, 14 academic papers on lift evacuation. If anybody would like more information, then please come and see me. We've pioneered this qualification, which is endorsed now by the Institution of Fire Engineers. It's a 1-week course in tall building fire safety management, so it's a specific course for managing fire safety. It takes 5 days. There is an exam and an assignment at the end. This is our last class of people that graduated in London. And I'm conscious that I'm almost out of time. If you would like to know more information, then please contact me, or you can join us on LinkedIn on the Tall Buildings Fire Safety Network, and you'd be welcome to join us. Thank you for your attention.